Hello everyone. Uh, this is Brefixy. Hope you guys are doing well. Today, what we are going to do is basically demonstrate how to build TensorFlow Lite GPU version for Android devices. Uh, and this build is basically a build of C++ libraries. So you need to copy the C++ headers. You need to copy this Android ARM 64 builds libraries.so files inside your Android Studio JNILibs folder. Header file should be inside your C++ encode directories. Alright, so our target is very simple. We'll write a single script which will download all of the dependencies. We'll clone the TensorFlow repository from Google's GitHub repository, and we'll check out a specific version branch from the Google's repository and build it using the Bazel framework. So let's start. The script is basically a shell script, so I'm using Vim to write this shell script. So build android.sh, the shell script. Now let put set -e command to make it executable. This is to indicate this is a shell script. And as we mentioned that we are building it for Android platform, we need to have Android NDK, we need to have Android SDK, we need to have the SDK manager to download the specific Android SDK. But before that, we also need to set the TensorFlow version, which branch we'll check out, and the TensorFlow directory also. So let's do this. Here we have put the TensorFlow version to R2.11. This is the latest. Then we put the TensorFlow directory. Directory is basically where the build script is. Here you will see a TensorFlow folder. We'll create the TensorFlow folder. Okay, and now we need to set. Export will basically set everything in your environment for the specific script or specific command line tool. So here we have put the Android NDK directory. So this is an home. Inside your home there will be an Android directory, and inside that there will be, we'll use the Android R21 and API level is 28 as we are targeting the Android 9 platform, Android 9 operating systems. And the tool, this is basically the command line version of the Android SDK manager, and we are using the SDK APIs. Android API is 28, so API level is 28 as you can see, and SDK directory is also the home Android SDK directory. So it will be created in your home directory. We are using the Ubuntu 20.0.4 as a host system to build and clone and build the TensorFlow code for the TensorFlow Lite GPU. Second, we need to write a function which will log from your build script. So this function is a shell script function which will write down wherever you want to put some log, you just call this function. Here, what it will do, this portion of the script code will basically check if there is any already downloaded Android NDK home. If not, then it will create an NDK directory inside your home directory, Android directory, and then from the Google download repository, it will download the Android NDK. version 21 or 2. You can change the version if you want. Current latest is at 25. You can also put at 25C or whatever in here. It will download it and unzip it to the home Android directory. I mean the root Android directory, and after done, it will delete this Android R21E. So your Android NDK is done. Now we will download the Android SDK. So this command is also similar. It will just check is that if there is any Android SDK home available. Android SDK previously downloaded on the SDK. If not, it will create the SDK directory inside root, and then it will download the Android SDK using the SDK tools from the Wall Street. SDK tools is basically CLI uh, form of Android SDK manager. You can see there is the Android SDK manager, and this basically downloads the Android platform. Android SDK for Android 20, Android API level 28. So your SDK will be downloaded. After the SDK download is done, you need to download few other. You need to create two other function. One function is to remove any unnecessary objects or uh, during the build process. If any unnecessary thing happens, RMD will be like create to remove the directories. And then there is another one. We need to, after the build is done, we know the library will be available on the lib directory, but we don't know where the header files will be. Header files will be inside the specific directory of TensorFlow, and then other dependency like flat buffers and com Google's IBSL. So you need to copy them and then put them inside include directory, because you cannot use the lib dynamic libraries like the ndk build lib.so without the header files or interfaces. So you need to collect the interfaces. Okay, so let me go by this one. So we created this function. You can see there's a collect headers. So it will first go to the TensorFlow Lite directory, and it will run a find command to find all of the headers recursively, and then create a tar file. It will also do the same thing. As you know, we'll use the Bazel system to build this TensorFlow Lite. So it will go inside the, it will execute, it will search inside the Bazel TensorFlow externals libraries. The flat buffer is an external third-party libraries, and it will collect all of the encode from the TensorFlow Lite flat buffers. It will do also the same. This com Google ABSL is required for the TensorFlow GPU. So if you want to use the TensorFlow GPU API, you need this com Google ABSL. So it is on the TensorFlow repository externals. So we need to also get all of the headers from there. So as you can see, we are basically did a find search and then creating a BSL.tar and created a tar with that. So we need to move all of the BSL. This directory is basically this directory is our distribution directory. Distribution directory we created on the same directory where our build script is. So all of the header, star, and everything will be there. After we move uh, all of the include header, BSL header, we'll create specific TensorFlow uh, includes. We'll create flat buffer includes. We'll create com.google ABSL includes and extract all of those tar files that are collected by a find command. Okay, then your include header is done. Now what we'll do, we need to set, we need to create a function which will build our TensorFlow libraries, right? So what will here this build arc function will basically build the TensorFlow Lite using the Bazel command. So we basically specified this inside the TensorFlow repository, the Lite directory, and C codes. We need to build them for these TensorFlow Lite C interfaces, and then there is a TensorFlow Lite GPU version. We need to build them for the TensorFlow using this command. We need to build them for the TensorFlow Lite GPU. We have specified that it will be a binary release, and we also strip this, so the size will be lower. Then we'll need to create the Android directories, library directories, where our builds GPU and CPU folder will be. After build is complete, we'll take all of them Bazel, as we are using the Bazel. All of the libraries will be inside the Bazel bin, so we need to copy the Bazel bin headers to our distribution directory. So we have done this. All right, when it is done, we need to do another interesting. We need to build function is done. Now we need to execute the build command, right? To execute the build command, we'll make our script such that you can provide the specific TensorFlow version to build. So I will do it. Let me show you. So first of all, we'll put the architectures, what architectures and ABIs we want to build for. So here you can see we are using the Android ARM64. You can use any other from the commented portion. We are using the ABI ARM64B8A. Alright. So now we are putting the distribution directories and the TensorFlow Lite directories, the TF directories, right? So this portion of the script will help you if you only execute, let's say, dot build dash android dash ish without any branch. It will use the default branch that you set at the beginning of the script. Okay, this portion of the code will create your clean your distribution directories and create the lib directories and include directories. Now let's clone the TensorFlow source code and also download and install the Bazel. So this code will basically clone the TensorFlow source code from the TensorFlow repository with the specific TensorFlow version that you mention, or if you don't mention, whatever default we have. This portion of code will basically download the Bazel's binaries and put it inside the lib Bazel bin. Now we'll execute a Bazel clean command inside the TensorFlow directory. We want to clean if we did a pre-built sometime ago or whatever. So now we need to iterate through all of the architectures and APIs that we have set to build. You can build whatever architecture API you want for the Android platform with this build script. And at the end, the collect headers function will be called. After build is done, it collect header function will collect all of your include files, interfaces. That is done. Now let's execute it. You cannot execute it, right? So you need the CS, you need the ownership. And the csmod a plus x build.android. That's done. Now you execute the command r 2.11, which is latest. So I started building. As already I have this Android SDK. Let me show it to you. Okay. So let me go to the root slash Android, right? So this directory already have all of those SDK. I will remove those rm minus rf Android. Okay. Done. So that is it's as I said, like it's a very huge file, so it will take some time. So now I go to our Lite directory, and we execute build and retrocesses R2.11. So you can see it's downloading all of the NDK and everything. Also, so this 100 NDK is around 1.1 gig. So it's downloading. My internet is pretty fast, but let's see how it goes. So it's downloading the Android SDK platform. Yeah, so your SDK will live SDK platform 20 is downloaded, and now it's cloning the TensorFlow. And the cloning is done, it will start building the TensorFlow Lite. Yes, your battle build is done. Start it. Bye bye everyone. Take care. Please make sure to subscribe my channel. I will try to put all of the build script to the GitHub and share with you guys. Bye bye.